A rational expression is the ratio of two polynomials. So for example, if you had something like x squared plus 3x minus 8, maybe you had a second one, x to the fourth plus 3x cubed, and you divide those two things together, we call that entire thing a rational expression. Rational, just like for a rational number, if you had something like, a half or 2/3 or something like that. The focus of this lesson is going to be how to multiply these and how to divide them. And the way it works is exactly the same for if you were to use numbers. So maybe just a quick reminder, if I said, what is 2/49 times 7/8, you could directly just multiply the numerators and multiply the denominators. So you could do 2 times 7 and then 49 times 8, that'd be fine. But it makes a lot more sense to simplify the expression before you multiply because the numbers will be smaller at the very end. So by that I mean, instead of just directly multiplying across, I know that, 7 goes into itself once and it goes into 49 7 times. 2 goes into itself once and into 8 4 times. And now if I multiply the numerators and the denominators, it's easier. You get 1 on the top and 28 on the bottom. That's the strategy we're going to use in example 1. You could just multiply these two by multiplying the numerators and the denominators, but let's try to cancel common factors first. So step 1, looking at these two, I need to factor them. I can't simply just cancel like this x and that x, or I have an x here, I can get rid of one of those up here. You're only allowed to cancel factors. So I'm going to first factor the numerators and denominators. For x squared minus x, I can take out an x and I'm left with x minus 1. And that was for the numerator of this fraction. I just removed an x. The denominator is factored. I can't do anything with it, so I'm just going to leave it as x plus 5. And this is being multiplied to 2x plus 10 over x minus 1. I can't factor x minus 1. I'll leave that alone. But the numerator has a factor of 2 that I can remove, so I'm going to do that. Take out the 2, and I'm left with x plus 5. Everything is now factored. You could even put some parentheses around the factors in the denominator if you want to. You don't have to, but you can. I now see that there are common factors between the top and the bottom. I have an x minus 1 that I can cancel with this x minus 1. It's just 1 that's left over. And likewise, I have this x plus 5 that I can cancel with this x plus 5. No other factors cancel, and I can simply multiply the numerators and the denominators together. In the top, I have x times 1, which is just x, and I don't want to forget this 2, so x times 1 times 2 times 1, that's actually 2x. The denominator is just 1 times 1, or just 1, and we can write this as simply 2x, since dividing by 1 doesn't change the value of the numerator. And so here's the answer. This whole thing when multiplied is equal to 2x. Canceling common factors first makes this process easier. So let's try this again in maybe a slightly more complicated example. So same idea though. I want to look to the numerators and denominators, factor them apart, and see if any of those things cancel. And I think they will. So maybe just to give myself some more room here. Starting with the first fraction, the first rational expression, the numerator is x squared plus 5x plus 6. I'm thinking maybe if this factors nicely, we could guess what the factors are. So I'd have to have an x and an x. Everything is positive, so I'll put some plus signs. I need two numbers that multiply to 6 and add to 5. The only numbers that work are 2 and 3. And that's it. I factored the numerator. All right, for the denominator, I see that there's a common factor of x squared that I can remove from both terms, so I'm going to put that as a middle step. I'm going to remove the x squared, and what is left over is x squared minus 16. All right, now let's focus on I'm sure there's more we can do there, but let's now move to the second fraction. So again, I have an x squared that's a common factor that I can remove from those two terms. So I have x squared and an x minus 4 that's left over. And in my denominator, let's see, if that's going to factor nicely, I have to have an x and an x, a positive and a negative. I need two numbers, that multiply to a negative 3 yet add to a positive 2, I think that has to be a positive 3 and a negative 1. Product is negative 3, the sum is positive 2. So this is looking pretty good, but I'm noticing that, okay, I could have taken it one step further here. So I'm going to break this thing apart. This is actually a difference of 2 squares, right? That's x squared minus 4 squared. We actually had a formula for this where, okay, I think I see how to break this thing apart. I'm going to rewrite this whole thing again. The numerator of the first fraction was x plus 2 times x plus 3, but the denominator, that's actually x squared times x minus 4 times x plus 4. If we multiply this out, my middle terms of the 4x's cancel, leaving me with an x squared and a negative 16. And I can't do anything with the second fraction because I completely factored it. And I'm at the stage where everything is canceled. I'm now simply going to cancel all of the common factors. Let's see. I see this x plus 3 cancels with that x plus 3. This x minus 4 cancels with that x minus 4. And I have an x squared that cancels with those x squareds. I don't see anything else that can be canceled. This leaves me with, on the numerator, x plus 2, and in the denominator, x plus 4 times x minus 1. At this stage, it's customary to leave things like this since we've canceled common factors. I mean, you could distribute the denominator out and write it as something squared, and you don't really need the parentheses in the top, but I think this is an acceptable answer for what we're doing with these problems, where I look at the two fractions, factor them apart, cancel all the common factors, and once we have that in one fraction, this will be our final answer. Now that we know how to multiply rational expressions, how do we divide them? The idea we're going to use is the same thing for if we just had numbers that we were dividing, like fractions with whole numbers. So maybe just a quick example would be something like if I had 2/9 divided by a third. What we would do is, according to this formula, switch this to multiplication provided that we flip the second fraction. So this problem is equivalent to 2/9 times 3 over 1. And then at this point, we know how to multiply, and we're going to cancel some common factors. 3 goes into itself once, and it goes into 9 3 times. Once we multiply, we get an answer of 2/3. So the idea is the same. I want to change this problem to multiplication and then cancel common factors. If I use that idea in this problem here, all I'm going to do is write multiplication and then flip the second fraction. Let's check that out. This is equivalent to 2x squared plus 4x plus 2 divided by x plus 7 multiplied by x squared minus x over 4x squared minus 4. So now that it is multiplication, I'm going to use the process we used in example 1, where I'm going to take both rational expressions and factor them. And I'm noticing in the very first fraction there's a greatest common factor of 2. So I can take 2 out from every term, and that's it. So I'm going to do that. This is really 2 times x squared plus 2x plus 1 divided by x plus 7. This is multiplied to, if I look at the numerator of the second fraction, again, I see this common factor of, I can take an x out from both terms. That is x times x minus 1. And there's a greatest common factor of 4 that I can remove in the denominator. That's 4 times x squared minus 1. So I see I could start canceling a little bit, but I'm going to continue to completely factor the numerators and the denominators. This probably can be factored apart, and so can a difference of 2 squares. So that is 2 times, we actually have a formula for this. This is going to be x plus 1 times x plus 1. The reason is you get an x squared, a 1, and you would double the middle term. So you could either recognize that as a formula or just simply put, I know this is x plus 1 times x plus 1. Maybe I'll put some parentheses around the x plus 7. Going back to the numerator quickly, the reason this works like this is you get x times x, which is x squared, 1 times 1, which is 1. If you look at the middle terms, you get a 1 times x for both the inner and outer, so when you add them together, it gets you a 2. So you can still use a guess and check approach, but we do have a formula for this as well. So now moving on to the second fraction, we still have x times x minus 1. That cannot be simplified, but x squared minus 1 is a difference of two squares. It's x minus 1 times x plus 1. Here, when I multiply this out, you get x squared, you get negative 1, but since I have a negative and a positive, instead of the middle terms doubling, they cancel to give you 0, which is why it doesn't appear here. Anyway, everything is completely factored. I can now start canceling any common factors. Here we actually have some numbers. 2 goes into itself once, and it goes into 4 2 times. We also have x plus 1 cancels with this x plus 1. We could have picked either of the x plus 1s, that's fine. An x minus 1 cancels with an x minus 1. And nothing else can be canceled. I can simply now multiply the numerators and the denominators. In the numerator, I have x times x plus 1. And in the denominator, I have 2 times x plus 7. And I would leave the answer just like this. Again, you could distribute the x, you could distribute the 2, but at this stage, I don't think much is gained from that since I've canceled all common factors, and this is the final answer.